Hi everyone. In section 1.2, we're going to graph functions using our usual setup. So we're going to graph a function f in the xy plane, where y is a function of x. So we have the equation y equals f of x that we want to graph. This graph will consist of all points of the form x comma f of x, where x is in the domain of f. So we're going to graph all points corresponding to these ordered pairs, where we have these values in the domain of f and these function values as their corresponding y coordinates. That's a key thing to remember. In the usual setup, function values are y coordinates. Function values are y coordinates. The outputs are y coordinates for points on the graph. Basically, x corresponds to domain, y corresponds to range. X is the inputs, y is the outputs. X is the independent variable because it's the input variable, it's what we plug into a function. Y is the dependent variable, it's the output variable, because the function value typically depends on what the input value is. What your calculator spits out usually depends on what you enter into your calculator. The calculator button would be the function. Now, by the way, in section 1.8, we're going to talk about x as a function of y. That's later. Also later, in sections 1.3 and 1.4, we're going to discuss basic graphs and how to manipulate them. But let's say for now, I give you a function, y is a function of x, and you have no idea how to graph it. How can you do it brute force, from scratch? We can use point plotting. It's a last resort, but it's there. So first of all, you need to consider the domain of the function f, and you're going to choose several values, several x values in this domain. For each of these x values, you're going to find the corresponding function value. Function values are what? They're going to be y coordinates. You're going to graph the corresponding ordered pairs, x comma y, x comma the function value. You're going to graph these points in the xy plane. So you're going to graph the points from your table, and then you're going to basically connect the dots, interpolate, and then extrapolate, go beyond as seems reasonable. So there is some guesswork here. Okay, as an example, we're going to graph the square root function, where f of x equals the principal square root of x. In other words, we're going to graph y equals root x. In the usual setup, we can replace f of x with y. Function values are y coordinates. First off, it would help to consider the what of the function. This is often the first question we ask about a function. What is its domain? What is its domain? Well, what are the legal values for x? What guarantees that we will keep this real? If and only if x is, again, non-negative. X must be non-negative. The domain of f consists of the set of all non-negative real numbers. Bracket, 0, comma, infinity, parenthesis. Remember, the square root of 0 is 0. That's legal. So, for example, positive 9, For example, positive 9 is in the domain, but negative 9 is not. Positive 9 is in the domain, negative 9 is not. So when you construct a table, you might want to plug in x equals 9, but you would not plug in x equals negative 9. You know that you're not going to have a point on the graph where the x coordinate is negative 9 or any real number, or any non-negative real number for that matter, which means you're not going to have any piece of graph over here for negative values of x to the left of the y-axis. So here's some good sample values of x to plug in because these are perfect squares. The square root of 0 is 0, so 0, comma 0 is on the graph. Over here, the square root of 9 is 3. The function value is 3, so that's our y coordinate. We want the point where x equals 9 and y equals 3. That's this point over here. In principle, we want to graph all points of this form, x comma f of x, where x is in the domain of f. We do definitely want this point 0, 0 here because that's an endpoint. We want to clearly indicate all endpoints on the graph. Notice that 0 is the endpoint of this domain here. We're going to want to plug in x equals 0 to find out the endpoint for this graph. You must indicate endpoints. Over here, we assume that the graph extends on and on. Some people put an arrow, but even without the arrow, if the graph extends to the edge of the figure, we assume it goes on and on as expected. So we point plot these 4 sample points, we interpolate, and we extrapolate. We go beyond. Now you can graph these things on Desmos, but bear in mind that even Desmos might mess up sometimes, so it helps to know what's going on. Often, nothing beats the human mind. Graphing utilities might get confused. All right, next up, we're going to talk about how to tell when a graph represents y as a function of x.